All right, so here we are to talk really quickly about lipids. Lipids, the first I can statement is I can name the parts of a lipid, specifically a triglyceride, and tell why a lipid is not a true polymer. All right, so a lipid, this is a triglyceride. It is made of two parts. This part is the glycerol. These are the fatty acid tails. So 3 fatty acid tails. And that is one of the reasons it is not a true polymer, because polymers by definition are molecules that are made up of the same repeating parts. So an amino acid, another amino acid, another amino acid, or a monosaccharide and another monosaccharide, another monosaccharide. Because this is made of two different molecules, glycerol and these fatty acids, it is not the same molecule repeating, so it is not a true polymer. All right, the second I can statement is I can give the atoms found in a lipid and describe how you can tell it's not a carbohydrate. Okay, the atoms found in a lipid are C, H, and O, and they are not in a 1 to 2 to 1 ratio. So carbs are, lipids are not. Generally, what you're going to see is very few oxygens. So for example, C12H26O2. Okay, definitely not 1 to 2 to 1 because these are nowhere near each other, 12 and 2. So that's how you can tell it's not a carbohydrate. The next is I can list at least 5 functions of a lipid. All right, one function, probably the main function that we don't necessarily love is long-term energy storage. That is why we have fat on our bodies. It's to store it for later. We don't like it, but that's what it's for. Another is for warmth or insulation. Whoops, I didn't spell that right. Warmth or insulation. We don't necessarily do this. We use clothing for warmth, but something like a whale that has a big layer of blubber would be using it for warmth or insulation in the cold ocean. Organ cushioning. We do use this. We have a lot of fat around our major organs like your heart, and that is just providing kind of a shock absorbent. So if you were to slam your body, let's say you were in a wreck and you slammed against the steering wheel, it's going to absorb some of that shock and protect your heart. It is used to make up cell membranes. We'll talk about that one in just a second. But your cell membranes are made primarily of lipids. And then another is communication, because some of your hormones are lipids. They are lipid hormones. You also have protein hormones. But so communication or your body talking, one part of your body talking to another. The last I can statement that deals with lipids is I can identify the hydrophobic and hydrophilic parts of a phospholipid and tell why this molecule is called amphipathic. So when you're looking at a phospholipid, basically what you're having is this top fatty acid tail is not there, but instead it's a phosphate group. So imagine getting rid of this and putting a phosphate group here. So you have that phosphate head and those two fatty acid tails, and this is how we show it, kind of our shorthand. So this is the phosphate head. It is polar, which means it likes water. So it is hydrophilic. Phil coming from the prefix that means to love, like Philadelphia is the city of brotherly love. So it loves water. These guys down here, the fatty acid tails, are nonpolar. And we know that polar and nonpolar don't like each other. So these are nonpolar, which means that they are hydrophobic, meaning that they fear water. They're going to do everything in their power to stay away from water. And this is why we form a phospholipid bilayer in our cell membrane. We'll talk more about that in Unit 2. But it's to protect these tails and keep them away from water. Anytime you have a molecule that has both hydrophilic and hydrophobic portions on it, that is called an amphipathic molecule. Amphi means both, path means condition. So it has both conditions in the same molecule. And that is everything. So if you have any more questions about lipids that I didn't answer or want me to explain something else, let me know. And I hope that helps.